about again what is Hadoop videos for these. You have already attended the demo sessions earlier. But this session also will have some brief input about what we have discussed in last session, and apart from that, we will see what will be our environment where we will work, right? Because we try to simulate a real-time environment here, and we try to set up a mini environment on your systems as well. So today I will provide you guidelines that what all softwares we will be using, and those softwares which we are going to use will be made available on your PC also, because all those softwares are open sources, and when it comes to commercial products, we do have virtual machines available free of cost for download. We'll be using those virtual machines in order to actually illustrate how actually these commercial Hadoop products work in market, right? Now, apart from that, we are going to set up a multi-node cluster where we will be using racks and all, which we will do on cloud. We will provide you access to the cloud as well, so that you can have hands-on on that, right? Now, if you ask me what is basic objective of this particular, you said training, this particular training is to make you market ready not only for development but also for administration, right? We know that when it comes to development or administration, we do need some prerequisites. As part of this training, we are going to provide you those essential prerequisites as well, which are required in order to work as an administrator as well as a developer, right? So you can ask me questions when we proceed further. I'll be telling you what environment we will be using, from where we will get those downloads in this session, and then next session onwards, we will start up setting up our Hadoop cluster, and we'll start up with building the ecosystem of our Hadoop, so that we are aware about internals of Hadoop, how actually Hadoop setup works, how actually Hadoop is integrated with external environments like RDBMS or ETL products which are there, and in what way you will be writing or doing your analytics using various existing interfaces which are there, which includes Java, which includes Hive, which includes Pig, which includes HADOOP, which includes Scoop. So we are going to integrate almost all products which are essential to be member of Hadoop development as well as administration capability, right? Now, in case if you find any voice lag or any disturbance in the network, you can write it on the chat box so that we can correct it, right? So we all are set to go now, and we are going to start with introductory session where we will have brief introduction about Hadoop, and then we will try to set up environment of Hadoop, right? Fine. So we'll start now. Okay. Videos, Farid, David, can we start? Right. Now, first question that we need to ask here is why we are going with all this, and what is problem, what is the gap in existing architectures, right? For which we need to understand few basic concepts like what is the existing architecture and your data. So if you see now, today's architecture will contain sophisticated components, because now today one single enterprise application cannot exist on its own. It has to talk to various other enterprise applications which are there, and you will find that almost all enterprise applications are diversified in nature, right? For example, if I go and if I try to book a ticket, I'll be using a provider, a travel provider. That travel provider in turn will talk to a number of airlines providers, and then probably it will give us the search results that which flight actually suits our needs. And then we will go with the selection process and the booking process, right? So if you see the workflow here, your request will be processed by a travel product, and that travel product will talk in turn with a number of other airlines providers products, right? This is what is one of the scenarios. Now, what happens when actually integration grows, when actually you have to talk to a number of other providers, you'll find that volume of data increases. You'll find that variety of data increases, right? And at some or other point of time, that particular volume crosses your capacity of handle that data, your capacity of handling that particular diversification of data, right? And when that situation is reached, we call it as we need now big data solution, right? So first we will see what is basic definition of big data. and then we will move and we will talk about what all solutions are there and how those solutions are actually implemented in big data domain, right? So if you see what is big data, as I told you that in your architecture, as soon as you reach the threshold of handling volume and complexity of data, you can say that now your requirement has reached where you have to term the data as big data, right? So you can say that big data is a term for a collection of data set which is very large and complex, and it makes your architecture prone to crash because of problems which are created by this particular big data, right? So you can say that complexity of data and volume of data, apart from velocity with which rate data is coming to your system, makes your existing architecture fail, right? So what you need to do is you need to adopt a solution to manage this particular big data, right? Now, in order to manage big data, you need to understand that how actually this big data is managed and what are different sources from where actually you will get this big data, right? So if you see, you will have various technologies, various tools, various providers from where actually data will now come to your system, right? Today you cannot actually compromise with data because everyone is in need of data, and data actually provides business capabilities to your enterprise as well, right? So if you are poor in handling data, you will lose lots of business which is there out in market. So everyone has realized it, and this is the reason why everyone is trying to adopt some or other solution in order to manage data, right? So if you see, these are various sources or various types of data which comes in from various sources which probably you have to handle, right? So if you see ERP, SaaS, cloud, web, CRM, data files, legacy systems, then you have messaging queues, you have customer service, you have analytics that you have to do, you have metadata, e-commerce, healthcare applications. Apart from healthcare, you have various other domains. So if you see, all these data has to be managed by you now, probably not all, but yes, definitely some of them, right? Because you cannot compromise with loss of data now. Fine. So this is what is the area from where actually data is called, and we call it as data explosion, right? Because now your system has to manage that particular data explosion. It's up to you what choice you are adopting. Either you are going and incrementing the existing system which is there by scaling it up, by adding more servers to it, by buying more sophisticated servers, costly servers, increasing the hardware capability, or you are looking for a cost-effective solution, right? Now, when it comes to handling big data, you will find various solutions which are there today in market. Now, one of them is HADOOP as well, right? So let's see what all challenges are there first in order to manage huge data, right? If you see volume, very important to understand. So if you do big data analysis for your architectural needs, you need to identify the volume of or scale of data which your architecture has to handle, right? For which you have various metrics, where you have various benchmarks that you can use in order to identify the volume which your existing architecture can handle and volume which you are supposed to handle once your architecture's capacity is over, right? Second, today you are handling data which is only in form of XML, but tomorrow you have to probably move and handle data which is not only in form of XML, but it's also in form of JSON, it is in form of you say Java objects, it is in form of data which is coming from RDBMS, it is in form of data which is coming from ERPs like PeopleSoft and SAP, right? So that actually provides you input that now I need a system which is capable of handling variety of data, right? Then comes velocity. Velocity means with what speed data is coming, right? So you have to do again benchmarking that what is the existing velocity which my architecture is handling and what actually will be the need after a particular period of time, right? Then comes veracity of data, which talks about uncertainty of data which comes from external environments, right? So these are 4 challenges actually which you have to handle using your architecture, right? So what are the choices of handling it? That's what becomes very important. So if you see, choices can be made after identifying your big data needs, right? So big data technologies are actually grouped into 2 different categories. One is operational big data and second one is analytical big data, right? When we talk about operational big data, it means now I need support on big data when it comes to interactive workload or interactive activities that you have to do on big data. For example, capturing the data and storing the data. That means you need to have big data systems which are capable of providing you capability in order to manipulate data which is there in big data storage, right? So they are actually called as operational big data. One of the big data system which helps you to handle it is MongoDB, right? Now, second one is very important. This talks about analytical big data. It means what? My data will be present in the file system, and now I have to write good analytics using best possible programming model in order to get the required analytical results. Okay. For example, if you talk about Google, Google has huge volume of data in terms of web pages. And now its web crawler has to crawl across various or huge amount of pages in order to give the search results, right? So Google has to do something so that it can store data properly, and then it can have an analytical approach in order to analyze the data which is there on the file system, right? So from Google, actually, with white paper which was released by Google in form of GFS, which stands for Google File System, and MapReduce, a system was derived which provided a powerful analytical system, and that system is what is called as HADOOP, right? So HADOOP provides you analytic capability, right? Now, why only HADOOP we are talking about? Because you do have certain other solutions for doing analytics, but problem is they are costly, right? So it depends on value of data that you are going to fetch from the existing data mine, right? If you want cost-effective, reliable, open source, right, easy to work system, probably Hadoop is one of the better choices, right? So if someone is asking you, is Hadoop enough for big data? You can say, no, Hadoop is not enough for big data because Hadoop takes care of a particular part of big data, and that is analysis, right? If someone asks, can't we get operational big data capability from Hadoop? Answer should be yes, we can get by using an ecosystem product called as HBase, right? But HBase does not have that level of capability which probably is provided to you by MongoDB and Cassandra. So if you see companies will not only use Hadoop, they will use Hadoop plus MongoDB plus Teradata plus Cassandra, right? A huge number of big data products. Okay, David, is that clear? Farid, is that clear? What is operational big data and what is analytical big data?
Yes.
Okay, good. Fine. So if you see, these are various technologies. Now, what is Hadoop? Since it is introductory session, I have to tell you what is Hadoop, right? To be very simple, Hadoop is a software framework, right, that provides you capability of implementing a file system which is present across different commodity hardware, right? When I say commodity hardware, please understand that these hardwares are not sophisticated hardware. These hardwares are normal hardware on which you have normal operating systems like Unix, Linux, Windows running. Okay, so it provides you a cost-effective approach. Instead of buying AIX with I-series kind of servers, you can use your existing commodity hardware and their storage capability, their manipulation capability, their processing capability in order to handle your big data, right? And Hadoop provides you capability of building up a reliable file system called as HDFS, which is derived from GFS, and it provides you capability of submitting your analytics job, which is called as MapReduce. Once analytical job is submitted by a client, your Hadoop framework takes responsibility of dividing it into n number of tasks and providing responsibility to various commodity hardware to execute that task in parallel. Okay, so instead of one process going and picking up data, you will have job divided into n number of tasks, and those tasks will go and actually execute the process, okay, on various machines, providing you capability of faster analytics of data or faster analysis of data, right? This is what is basic advantage when it comes to Hadoop. Is that clear? Right? So instead of having sophisticated hardware, you can use existing commodity hardware by setting up your Hadoop cluster and making n number of commodity hardware part of your Hadoop cluster so that processing can be done on huge amount of data. Right? So this is what is capability. Now what we are going to talk about. When we talk about setting up Hadoop architecture, we will work on both versions of Hadoop. It is Hadoop 1.0 as well as Hadoop 2.0. Okay. All these various, okay, David is asking a question. All these various OS then has to be put on HDFS. Yes. Right. So usually what we can say is HDFS is a higher level of abstraction, right, which is aware about n number of commodity hardware. So whenever you place your request, your HDFS takes responsibility of distributing the data on various commodity hardware. Okay. So it is your HDFS which actually interacts with native operating system. As a Hadoop administrator or as a Hadoop developer, you will work on HDFS file system. An HDFS file system will take responsibility of talking to the native operating systems which are there on commodity hardware. Is that clear, David?
Yes, a bit, yeah.
Okay, good. So now if you see, there are two versions of Hadoop. One is Hadoop 1.x and second is Hadoop 2.x, right? Hadoop 1.x comes with two core components. One is HDFS, and please understand, responsibility of HDFS is to provide storage, to handle storage, to provide reliability, right? By ensuring that data is not only in a single copy, your HDFS will take responsibility of replicating the data and putting it across different nodes, you say, or boxes, you say, or machines, you say, in the existing cluster. So that in case if one machine is down, the data is still made available from other machine which holds a copy of the same data. Okay. The MapReduce is, and you can say now Hadoop contains another component called as MapReduce. So you will have Hadoop which contains MapReduce engine. That engine takes responsibility of executing analytics job. Okay, and it follows certain programming model which is adopted by Hadoop from Google again. It is called as MapReduce programming model, where it works in two phases. One is mapper phase and second one is reducer phase. So when we go and do development, we will see what we do in mapper phase, what is input for mapper phase, what is output for mapper phase, and how actually output of mapper phase is made input of reducer phase, and what is reducer's responsibility to give you the final output, right? So we'll talk in detail once we move further. But when it comes to Hadoop 2.0, they added extra components to it, right? They said that now we are going to give you much smarter MapReduce engine, which will not only include MapReduce, but we are going to externalize, we are going to decouple cluster resource management responsibility. For example, if you see here in Hadoop 1.0, MapReduce engine takes responsibility of not only data processing but also cluster resource management. But if you see in Hadoop 2.0, it is decoupled. MapReduce now is responsible only for data processing. You have another component called as YARN, which takes responsibility of cluster resource management, right? So it decouples your data processing from cluster resource management, right? So we'll see in detail how actually we can configure YARN also in our ecosystem product, right? Apart from this, Hadoop 2.x talks about other ecosystem products also, which are there in order to help you in managing your diversified data. Okay, it's clear. So I feel that basic difference is clear between Hadoop 1.0 and 2.0. What is basic difference, Mohit? Introduction of yarn in Hadoop 2.0, right? That's what is the basic difference?
Yes.
Okay. And what was the objective? Objective was to decouple, right? Decouple the responsibilities. Okay, fine. Now, right. So now if you see why we talk about these two versions, and when you go to your job list, why it becomes important. See, when you ask me.
Hey Niranjan, why 1.0 and 2.0? Both are same seems to be, but only they structure differently, right? In 2.0?
Yes. You see, architecture of the framework is changed now. Now you have three important components which will handle the responsibility.
Okay, three different.
Yes. That's what is the difference.
Okay.
Okay. Oh, fine. So we will be talking in detail on this once we move further. Now I was talking about why it is important, and when you go for interview or for jobs, like how it is going to affect. See, you will have various companies, and various companies will use various Hadoop products which are there in market. For example, Cloudera is there, then Hortonworks is there, right? Then you have MapR, then you have Pivotal. You have various products which are there in market, right? Now, first thing that you have to do is you have to see that the company uses which version of Cloudera, which version of Hortonworks, right? Because these products internally will claim that we are Hadoop 1.0 compliant or we are Hadoop 2.0 compliant, right? So when you start working on them, if you are working on Hadoop 2.0 compliant Hadoop commercial product, you need to understand that you have to work with extra configuration of yarn. Okay. Yes, so that actually provides you capabilities of your Hadoop, right? At the end of the day, all Hadoops, whatever are there in market today, whether it is Cloudera or Hortonworks, they are actually based on either Hadoop 1.0 or Hadoop 2.0. It means once we know core Hadoop, we will be capable of handling or working with any commercial distribution of Hadoop which exists in market today. Okay. Clear? Clear, right? How the resource management and reliable storage kind of same thing. Okay, no. See, Tejas, when it comes to resource management, right? Resource management is from perspective of resource which comes as a job. Okay. And when we talk about reliable storage, it is at low level where your Hadoop or HDFS ensures that whatever data you are putting, that data will not be lost. Irrespective of if one node is down, your HDFS takes responsibility of replicating the data on other nodes. Okay, so storage, reliable storage talks more about creating number of copies of data. Resource management talks more about how many parallel processes should be started. Okay, how actually your job will be efficiently managed. What is the benchmark that you are looking for? What is the throughput that you are looking for? So that configuration you will do in cluster resource management. Is that clear? Tejas, is that clear? Okay, fine. Now, let's talk about how actually this setup will be done. Okay, so I'll just add a few slides here with so that we can get proper understanding of what we are talking about. Now, I told you Hadoop 1.0 and Hadoop 2.0. Now, let me tell you how actually we'll configure that, right? So, when it comes to Hadoop 1.x, right, you will configure your HDFS in a file called as HDFS site.xml, right? When it comes to configuring your map reduce jobs, you will configure it in map red site.xml, right? When it comes to configuring name node, I'll tell you what is name node. You will be using core site.xml, right? It means when we talk about storage, HDFS site.xml becomes important, right? Hadoop works on master safe principles, right? So if you have assume 10 different nodes on which you want to install HDFS, right? You will be installing HDFS, marking one of the node as master, right? So this master node which you have marked must be high capability, and its responsibility is to manage overall Hadoop cluster. In short, it maintains metadata of entire cluster, right? And if you see, whenever there is request from client to do analytics, it is name node who guides the cluster to store data or even to execute jobs, right? Now question here is, what if my name node is down? It's a good question, because in Hadoop 1.x, if name node is down, it is considered as single point of failure, which was taken care in Hadoop 2.0. So when we talk about Hadoop 2.0, it provides you capability of configuring two different name nodes, where both name nodes will work with each other together, so that in case if one name node is down, other takes over, right? Rest of the nodes which are there are slave nodes, and these slave nodes responsibility is to store data, right? And this is the reason they are called as data nodes. If someone is asking you that what all will be the important component in Hadoop cluster, very simple: name node, data node. These two are important components. Okay, is that clear? In Hadoop 2.0, one extra component was added, that was YAR. And in order to configure your cluster resource management, you will be manipulating using a file called as yarn site.xml, right? So in all, if you ask me how many files are there which need to be configured in order to set up the cluster, these 4 files are important. Okay, is that clear? Mohit, is that clear? David, is that clear? Schedules? Okay, fine. So this is how actually you'll start working there, right? Now let's talk about important components of Hadoop, which we have already seen. As of now, we will talk from perspective of 1.0, and then probably we will move to 2.0 also in upcoming sessions. So if you see, Hadoop has 2 important components as of now. One is HDFS, which is name node and collection of data nodes, where if you see, name node is the master and rest of them are slaves, right? So if someone is asking where data is stored, please understand, data is not stored in name node. Data is always stored in data node. And what is there in the name node? Name node contains metadata about data nodes, that what all data nodes are there in this particular cluster. Whenever request will be there from client, it will not be directly made to data node. That request will be made to name node, and name node will tell the client that which all data nodes are there where actually data has to be, right? So these 2 components makes up your HDFS, right? Then comes map reduce engine. Map reduce engine is for executing your analytics job, right? So you will have two components which take responsibility of doing that execution. One is job tracker and second one is task tracker, right? Now responsibility of job tracker is to get the job and distribute that job to various task trackers. Okay, so for example, if you want to do analytics or if you want to search some keywords, right? That keyword which is stored in a file, and now that file is there in your HDFS. When we say file is there in HDFS, it means that file will be present in n number of data nodes, right? Job tracker will give responsibility to task trackers, and these task trackers will do actual execution of tasks. Right? Now, if someone is asking you where on what machine this job tracker should be there, best place to keep this job tracker is name node. And where these task trackers will be there? These task trackers will be there on the system where actually you have configured your data. Is that clear?
What?
Clear, right?
Yes.
Okay, fine. Now, next, elaborated HDFS component. Since it is introductory session, I will talk about what all capabilities are there, and then probably I'll move to showing you how actually they are set up. Now you see these are the important components. Look at the keywords or the terminologies which are being used. See, heartbeat, balancing, replication, etc. Right? What is this heartbeat? I have set up my cluster where I have some 10 systems or 10 machines on which I have configured my data node. One of the machine is name node, right? How my name node will know what all data nodes are currently up? It is only possible if your data node keeps on sending their heartbeat count or their heartbeat to name node. Now, if name node has not received heartbeat from one of the data nodes, that data node will be assumed to be dead, okay, or down, right? So it is heartbeat which tells your name node that which data node is actually running, okay. Whenever you do write operation, whenever HDFS client will do a write operation, that write operation will be managed by name node. Name node will tell client that what all data nodes are there which are near to him where he can write the data, right? Then comes replication. Fine, you are writing a file to name node. How many replicas of that particular data must be created? If you will specify replication or R equal to 3, it means when a file comes from HDFS client to name node creates 3 copies or 3 replicas of it, and it distributes it over various data nodes. Advantage, one data node is down, other data node takes over. Okay, is that clear? So it provides you reliability also. Fine. Now comes a scenario where we are going to write data to file, right? Just see how name node and data node coordinates with each other. First thing that you need to understand is that each HDFS will have a predefined size, right? For example, HDFS says that for me, maximum data that I can store is 65 MB. Okay. What if you are trying to write a file which is more than 65 MB? If it is more than 65 MB, immediately what name node will do? It will create n number of blocks, right? So it will split this file into n number of blocks. So if you see here, file.txt has been split into 3 blocks. One is block A, block B, block C, right? After it has split it into blocks, your name node will tell that now you can go and store these blocks on these data nodes. Data node 1, data node 5, data node 6, right? If you see now, once name node tells the address to the client goes and writes it to the notified data nodes which are told to him by name node. Is that clear? David, is that clear? So you should ask me how actually I will write data to HDFS. You need not worry because you have HDFS commands to do that. Like in Unix, you have commands to write data to file. You can use cat in order to create a file. You can use cp in order to copy a file. similarly, in HDFS also, you will have certain commands which you will use in order to write data to HDFS from local file system, or you can use interfaces like Scoop in order to get the data from database even. Okay. Am I clear? Fine. Right. Now here name node tells what data nodes. Apart from this, in order to get reliability, we can have replication of this on various nodes also, and that depends on you, how many replicas you want. More reliability you want, you have to go with more replications. But if you go with more replicas, probably you will be using more resources. So do a benchmarking of your case, see what data is sensitive, where you cannot bear the loss, and then maintain the required number of replicas. Okay. Fine. Now, let's see what happens when a data node fails. And please understand that all these are implicit. Once you set up your cluster, once you specify the configuration parameter, your Hadoop framework will take care of it. Okay. Now, if you see, name node is a master and these are data nodes. You are writing two files. One is data1.txt, second one is data2.txt. Okay, see, it does it with stripping with parity also, David, right? But replicas are considered as much better because you will have duplicate copies distributed across different data nodes. Okay, so, and it depends on the failure scenarios also. So, for example, this is one of the scenarios where your data is stored and you have R equal to 3, and if you see, it is set up in HDFS site.xml. So once this data is stored here, it maintains replicas 1, 1, 1, right? If this fails, your 1 is already available here, right? Apart from this, your Hadoop, once it finds that data is not there in the data node because data node is now dead, what it does is it immediately tries to create a new replica and it will try to write it here. Okay, so if you see, it tries to write it to this particular place. When we go here, if it fails, it will try to maintain replicas always, which is equal to the factor that you have specified in R equal to. Okay, the minute it fails, the number of replicas reduces to 2. So your name node or your Hadoop cluster now smartly does what? It creates a copy of 1 and it writes it in another data. Okay, is that clear? Okay, fine. Now once again, when data node comes up, finalize. Replica is 4, so what it will do is it will remove that particular replica from there, and all this is taken care internally. Okay, fine. Now if you see map reduce architecture, we saw HDFS, which is composed of name node, data node, features that HDFS provides is reliability, failover, right? When it comes to map reduce, it talks more about your analytics, right? Now, if you see, map reduce jobs can be submitted using different interfaces. One of the interfaces is Java. You can use Java. Second interface is streaming APIs. Third interface is Pig. Fourth interface is Hive, right? All these are various interfaces which you can use in order to write your analytics. For example, if you're not very good in Java, you can go with Hive and Pig, right? But it heavily depends on company where you are going to work, right? What interface they are using, and you have to scale up your understanding according to the company's needs, right? We will make you aware about all 4 various interfaces which are there existing today in market. Okay.
Hello.
Right. Yes.
Yeah, I had a question. So, is
Yes.
it possible to work in Hadoop without knowing Java? I mean, how much does Java play a role?
Okay, see, I'll give you my frank opinions here, okay, without thinking much, right? If you say, do I need to know Java, right? I'll say yes. If you know Java, it will be added advantage for you. Now, why? It's not only for writing analytics, right? Whenever some problems will be there in Hadoop, you will get exceptions. Now, since Hadoop is written in Java, those exceptions that you will get will be in Java terminology, right? So, if you know Java, it will be easy for you to understand those errors.
So are you saying that if I don't know Java, then I cannot get into this space at all?
No, I'm not saying that. But yes, you can participate, or you can be, you say, part of Hadoop domain even if you don't know Java. Okay, you can write your analytics, there is no issue. You can write your analytics, you can do all tasks which are there, right? But if you know Java, since Hadoop is written in Java, if you know Java, it will be an added advantage.
Right, but if, let's say, I mean, I have just basic understanding of Java, and I am a data warehouse.
Yeah, that's
okay. So I don't need to be a hardcore Java developer.
No, not at all. If you know what class is, if you know what interface is, if you know what exception is, that's enough. And we are going to provide that prerequisite as a bundle of this course, whatever is needed from Java perspective.
Okay. And where are you located, Mohit?
Mohit.
Yeah.
Sorry.
My name is Niranjan.
Niranjan, where are you located?
Yeah, I am located in India, but I keep settling to US also. It depends on the project, nature of project. Now, since I am with Oracle and I work closely with Oracle and Google, I keep on changing the place. Sometimes like 4 months I'll be there in UK, 2 months I'll be there in US. I keep on settling my place.
Okay, Niranjan, is there a way for you to? Niranjan, I have to drop off. This is Deepak Mangani. I have to drop off. But is there a way for you to email me and I'll get back with you?
Yeah, you will be getting the video recording of this session as well, right?
Can you just send me your email address too? Can you just send me your email address too, please?
Yeah, sure, I'll do that.
Okay, and I will circle back with you after. Yeah, I will circle back with you after some time. Okay, because I have to rush somewhere else right now, but I'll circle back with you.
Sure.
Thank you so much.
I'm just typing. Thank you. Thank you very much. Okay. Now, coming back to our task, which is MapReduce. We have set up the Hadoop cluster now, right? And believe me, it's a bit of tedious task, but it's not that complicated, right? We need to know what entries need to be made. We need to draw our architecture diagram first, and then we need to go ahead and implement it. By end of this session, I will tell you what is an actual real-time architecture that we need to have, or we will get in companies when we move and when we are supposed to do work, right? And we are going to help you in setting it up as well, right? Fine. MapReduce. MapReduce is a programming model specifically written for doing analytics using Java. Using definitely internal is Java, but you can use various other interfaces which use for, right? What MapReduce does, see, like other algorithms, when we talk about sorting algorithms, you have coupled sort, you have heap sort, you have various sorts, right? You have to organize your program according to the algorithm that you have selected. Similarly, when we want to do analytics, we have adopted MapReduce. MapReduce provides you a specific programming model of handling your analytics, right? So MapReduce clearly says that I'm going to divide your job into two different parts. One is mapper part and second is reducer part, right? Mapper part will work on data nodes and reducer part will take responsibility of collecting the analyzed data on various data nodes to provide you the aggregate output of it, okay? So typically mapper phase will do tokenization, filtering, counting. In case of word count, this can be changed as per your need also. And reducer phase will provide you the aggregate results, right? So when your job is submitted, if you see immediately your job is divided into n number of tasks. Each task is submitted to a data node. That task is executed on data node. Each data node prepares an output, and all output of all data node are then passed on to reducer, where reducer takes responsibility of Doing what? Creating the aggregate output. Okay. So typically, if you see an example here, which is of word count, how it works, you see. You have a file called as bigdata.txt. You have stored it in your HDFS. Where HDFS does what? If size is more than 64 MB, it divides it into n number of blocks, where each block goes and gets stored on different data nodes, where these data nodes are typically present on different machines. Right? When you submit your job to count number of occurrence of different words, immediately your job tracker takes responsibility and distributes it into n number of task trackers. Now, since here we have 3 data nodes, you will have 3 task trackers, right? Each task tracker will then execute mapper phase, where it will collect how many occurrence of big data is there on the block which is stored here, how many occurrence of big data is there which is stored on this data node and on this data node, right? And they are creating a list of maps, right? You have here this map, a collection, where you have key, which is the word, and value, which is the count, right? This activity is done in mapper phase, right? So what will be output of mapper? Output will be a list of maps. Agreed, Farid? Tejios?
Yeah,
David?
I have a question.
Yeah.
You know, when anyone look for something, you know, for example, the green plum. So it's going to take, you know, from all HDFS green plum, you know, associated with the number, or is it going to go only on the specific, you know, value?
No, it will go to all data nodes and it will have a count of how many times green plum has appeared in the block which is present on that data node. Okay.
Okay.
You can say n number of parallel processes will start. This gives you benefit in terms of throughput, right? Instead of one process executing and finding out how many occurrences of what word is there, you have n number of parallel processes getting started. So execution will be faster. Okay.
Well, and data will not be duplicated, right? Duplicate
no,
data.
It will not be duplicated. It depends on the what actually analytics you are doing. Okay. Here, analytics that you are doing is counting number of words which appears in a file. Okay. Fine. Now, after mapper has executed, you will come to second phase, that is reduce phase. And if you see, reduce phase is doing what? It is creating aggregate, getting data from all data nodes and then telling you, see, big data in this file has appeared for 19 times, Hadoop for 19 times, green plum for 17 times, right? So you need to design your MapReduce program properly by identifying what you want. Second, identify what will be the output of mapper phase. Third, identify what you need to do in order to create the aggregate in reducer phase, right? So we will be looking at some 15 to 20 use cases of MapReduce, where we will take different type of problems which are there in today's real world, right? And we will be doing it so that you understand what should be there in mapper, what should be there in reducer phase. Okay, and we'll do it using Java, Map, Hive, Pig, and various other interfaces. Okay, is that fine? Right. Now comes, we spoke about core components, which is MapReduce and HDFS. There are certain other components also which need to be made available to your Hadoop cluster, right? For example, you want to get data from database and make it present on your HDFS, go and use Scoop, right? So this becomes what? Ecosystem product. So you have to decide what all ecosystem product you need, right? And you have to go and you have to set it up. If you go with Cloudera, if you go with various other commercial products, you'll find that all these setups are already done. This is the reason why first we take up Apache Hadoop and then we tell you how to integrate all this. You will be ready with your own stack of Hadoop actually. And then when you work with these commercial products, it becomes very easy for you because you will not face problem of integration and all. Right. So if you see, you have your server, on top of that you have operating system. Now you should ask me, for Hadoop, do we need always Linux? Answer is no. You can set up your Hadoop on Windows, on Linux, on or various other operating systems like Mac also. But in production, which one is preferred? It is Linux, right? On top of Linux, you have JVM because Hadoop is built using Java. It will start Java processes, so JVM is required. Then you have HDFS and MapReduce. Over network, you can have now Pig, Hive, Scoop, Evro, which has their own responsibilities. Then you have orchestration framework, where we are going to talk about these 4 frameworks. HBase for NoSQL capabilities, adding NoSQL capabilities, adding capabilities of column-based database. Then you have Chukwa, which we can use for performance and monitoring. Then you have Flume, you have Zookeeper. All these together can be used for orchestration, right? Then you have BI analytics, how to get data from BI tools, right? And you have external data warehouse connectors, how to use Pig in order to collaborate with external data warehouse. So this is what is going to be our ecosystem product. Apart from this, backup recovery, deployment, security and management, right? For security, we are going to use LDAP, we are going to use Kerberos. For management, which is monitoring and troubleshooting, we are going to use Gangalia, right? Gangalia, if you are interested in Nagios, or if you feel that your workplace needs a different monitoring tool, we can show you that also, right? But as part of this course, we are covering Gangalia, right? We will show you how actually you can manage your Hadoop cluster, monitor your Hadoop cluster using Gangalia. Why Gangalia? Because it is popular and it is open source, right? For security, we know we have to authenticate and we have to authorize. There is a difference. Authentication means, am I the right user, or is the right user trying, right? Where you will use username and password. Authorization means, okay, fine, you are the right user. Are you authorized to access all ecosystem products, or are you authorized to execute MapReduce job, or are you authorized to access HDFS, right? So you will have authorization and authentication that you need to provide. Authentication is done by using Kerberos, and authorization is done by using roles which you define in your LDAP. Okay, please understand, Hadoop is not aware about authentication, that you have to implement, right? We will do that as well. Is that clear? Serious? Okay. David, is that clear? Mohit? Good. Fine. Now let me draw here a typical architecture that we will try to set up. Yeah.
Can you please give me brief one more time? I missed out somewhere here and there.
Okay. About what? Security and management?
About the ecosystem, like what Hadoop play important role in this system?
Okay, see. When we talk about Hadoop, core Hadoop components are HDFS and MapReduce, right? Now, when we want data to be made, because Hadoop is big data, and big data talks about diversification, like diversified data, right? Where data can come to your Hadoop from various sources, right? So, question here is how I will make data which is there in RDBMS available in my Hadoop cluster. For that, you have a product. That product is what is called as Scoop, right? So if my need is to get data from RDBMS to my HDFS and then do analytics, I'll be configuring Scoop, right? Hive and Pig are these two other analytical systems which you can use instead of Java. So if you don't have professionals from Java background, or if you feel that you want to not go with complexity of Java, you want to use a better interface which is easier to write, you will go and you will use Pig and Hive. Now, in order to make your Pig scripts and Hive scripts interpretable, you need those engines to be part of your Hadoop cluster, right? If I don't have Pig engine, I cannot submit my Pig job. If I don't have Hive engine, I cannot submit my Hive job, right? So what I need to do, I need to configure Pig and Hive as part of my Hadoop cluster. so that whenever a pig or hive job is submitted, your interpreters which are already configured take responsibility of converting your pig script into map reduced jobs, right? So this is the reason why your Hadoop is complemented by n number of ecosystem products. Depending on your requirement, depending on your use, you can go and select one of them. Is that clear? We will be configuring all these ecosystem products. Okay. Now I was talking about security management deployment. So this diagram itself tells you what role you can play. See, first administrative role is to set up your Hadoop cluster, decide number of data nodes, decide name node, decide whether you want 2 name nodes, right? Decide number of jobs, decide number of task trackers, right? Decide how many parallel processes need to be created. So all those things need to be decided by you. Then you have to plan how I will take care of security, how I will manage my Hadoop cluster, how I will have monitoring system in place, right? So all these tasks are there in integrating all these Hadoop ecosystem, having monitoring system in place, configuring security. All these are administrative tasks. When you ask me what then developer will do, developer will focus on writing map reduce jobs. Developer will focus on pig scripts. Developer will focus on Hive, right? Developer will focus on bringing data from RDBMS and making it available over your HDFS, right? So you will have certain tasks which are distributed among developers and administrators. Objective of this course is to enable you in doing both. Okay, is that clear? Fine. Now just a brief. I know like most of you are already meeting the background which is needed. You see here for administration what is the prerequisite? Very simple. You need to be aware about Linux users commands, right? For example, as an administrator, you will like to know what all ports are there which are occupied. You will like to know what all permissions are there for me as a user on this operating system, right? You will like to search. You will like to create a directory. You will like to delete a directory. You will like to create files. You will like to search data from a file. So these are basic administrative, operating system skills which are required. We provide it as part of the course itself. For development, as I told you, pig and Hive. We are going to do it from scratch. Yes, Java is there. If you are not aware about Java, we are going to give you videos or live sessions in order to at least cover that part of Java which is needed by Hadoop developer. Okay. If you see, these are the prerequisites. Any confusion?
Niranjan?
Yeah.
I just wanted to ask, like, since I mean, so whatever the development that we will be doing something in industry, that will be like something whatever we will be writing, so that will be something equivalent to SQL in the form in some other format, something like that.
Okay, Mohit, if you see, right, for SQL developers, Facebook came up with Hive. Okay, so you can expect some advantage if you are good in SQL, if you are using Hive, right? So you will be using definitely queries, right? But it will not be 100% SQL. Certain keywords are borrowed from SQL so that you can feel comfortable. Okay.
So basically we will be writing some map reduce programs. Correct me if I'm wrong. So basically we will be writing some map reduce programs to currently map to currently write some equivalent query kind of thing which we usually do in SQL. Is it right?
You do it in Hive, and then Hive takes responsibility of translating it into map reduce automatically. So when you are using Hive or Pig, you will not bother about Java program or what mapper and reducer will do, right? You will be writing using Hive keyword and Hive programming language. So you will go through Hive and Pig programming language, which internally gets translated into Java MapReduce only.
Okay.
But you will be hidden from the complexity. You will write select from, a table where this equal to this.
Okay.
Okay. So it's like you will have n number of interfaces using which you will be able to write your MapReduce jobs, right? If you are using Hive and Pig, you need not bother about Java, because engines will take responsibility of translating your MapReduce, of translating your Pig script or Hive script into the relevant MapReduce job. Okay. Fine. What all commercial products we are going to supply you? It's Pivotal, Cloudera, Hortonwork, and MapR, right? So once you are aware about Apache Hadoop, core Hadoop, believe me, it becomes very easy for you to go and upgrade yourself in any existing commercial product. Okay, because at the end of the day, all are working on the same base, and that base is Apache Hadoop. Okay, they have definitely added some extra modules to it to simplify life of administrator and developers when they are using these commercial products. Is that clear? Then comes certification. Our course maps to these two certifications, where CCTH is for developer, CCAH is for administrator. Okay, so once you complete the course, you can go and you can write these certifications. We will provide you guidelines of writing these certifications. Also, we will provide you some questions on each topic which are expected in certifications. Right. So this is what is the support. Now comes lab environment. You can work on VMware, which will be part of your system, Ubuntu, Hadoop 1.x and 2.x. Apart from this, whenever needed, for example, database is needed, I will tell you how to install database. We will be using MySQL. If you are interested in any other database, I can quickly do it. Not only that, certain people will ask that what about Red Hat? So we can do it on Red Hat also. Okay. What about CentOS? We can do it on CentOS also. You need to just give the input. For example, when you go for a job, and if you feel that you are trained by us on Ubuntu and you want to quickly translate your understanding on other operating systems, you have to just call us and we will schedule a specific session on that particular operating system. Okay, because rest of the things will be similar. It's only commands, it's only the way you set up will be different, and that we can provide you. Is that clear? But we will try to target these three operating systems. Any questions, Farid, David?
No.
Okay, fine. So this is what is going to be our lab environment, right? Now, how actually we go ahead and set up? In order to set up, step one is to go and install. You have to go and install VirtualBox. Okay, and these all are free products, so no licensing issues and all will come in. If you see, I'll write here Oracle VirtualBox. You can go and you can take the right VirtualBox depending on your operating system. After you install VirtualBox, I'll assume that now you went through and you have installed. I'll provide you a step-by-step approach, and like initial session, like first session will be to install Hadoop, where I will be there with you for at least 1-2 hours till your setup is not done, right? You will be downloading it and you will be installing it. After you install it, depending on the operating system, you will get the software installed. For example, I'll go here. I have here application. In my application, if you see, I have VirtualBox installed. You see, this is what is VirtualBox. Right? No difference when it comes to Windows also. It's only the way you start. I'll just go and open it. So the minute you launch it, it will start up a program. You see, where I have, you see, 3 different virtual boxes on my machine. One is Ubuntu 10, second one is Ubuntu 13, third one is Ubuntu 13. Right? From where I'll get it? Very simple. You have a place where actually they distribute virtual boxes free of cost. Now this is virtual box. You have to download now machines. So you have here Trend Sigma Ubuntu VMC. I'll go here and you can download. And if you see, it is 768 MB, 40 GB is the hard disk requirement, and RAM that is needed is 512 MB. Okay, you will just download this one. Yes, so this is 12.4. Similarly, you will have various other virtual boxes. Right, so this is what is the source from where you download. See, all different sources: Fedora, OpenSUSE, Bodhi Linux, right, Ubuntu, Debian. All these are flavors. You can get the images. Is that clear? Once you will download, you will get. You have to just extract the zip. Once you extract, you will get your entry here in VirtualBox. Okay, and next what you have to do, you have to just go and start. All this process I will do along with you. Okay, once you start up with the setting up. So I am trying to start virtual machine now. I'll switch. As you see, this launches Ubuntu. So first session that we will start off will be to make you comfortable in all these environments and to have a proper hands-on on basic Linux commands so that you are comfortable in manipulating Linux or using Linux of different flavors. This is one way. Other way is you can use virtual machine from VMware also. Now if you see here, you have the operating system launched, right? Is that clear? Now I want to launch terminal. So if you see, terminal comes here. Now I can execute all Linux commands here. Is that clear? After you have this environment ready, you can go and check, is Java installed? For that I will write javac -version. It tells yes, Java is installed. If Java is not installed, what to do? How to install? Very simple. All that I will guide you. You can go and write sudo apt-get. Now it depends on the operating system. Like Ubuntu uses or understands apt-get. Install JDK. I am writing here 7 or something. Admin user. And if you see, it is saying unable to locate 7 because you will have various flavors from where actually you can go and you can download. That all I will tell you. As of now, one Java is there present on my system. Okay. So after checking your Java, your next task is to go and install HADOOP. So if you see, I have HADOOP versions. What I can do is I can download it from scratch. Sorry, let me just maximize the screen so that I'll just close it. And see, I want to set up HADOOP. See what I'm doing. Let's go here, google.com, and now I can decide I want to download HADOOP. Right, I'll go here to Apache, and here I'll go to download HADOOP. Right, and you can go here and see various HADOOP projects which are there. I'll go here. Now you can decide which release you want to. So if you see, these are various releases which are there. Assume that I will go with 1.2. Just telling you a bit so that you can get the feel how actually we'll be working out with practicals. Right? I'll download this 61 MB. Once you download this, once you follow this process, in downloads, you will get your Hadoop downloaded. Right? You have Hadoop here. What I'll do, I'll copy. After copying, I'll go to home and I'll paste it here. It's saying it's already there, replace it. It's simple. And then what you need to do, you need to just extract it. I'll extract here. This is how actually we'll be doing, and I'll make you do at your end also. I can make you presenter and I can see in case if any problem is there on your machine also. I'll just go here, and best part is all this is getting recorded. These recordings will be made available to you post session. Right now, what version should we download? HADOOP will be working with both 1.0 as well as 2.0. So first we will do setup of 1.0 and then we will do setup of 2.0 as well, so that we can work with yarn also. Okay, fine. Now if you see, after you download, you get all these files, directory structure. Now important directory structure directories are conf and bin, because bin contains all your utilities that helps you to start the processes and stop the processes, and conf contains important files which you have to configure, like course site, right? You have SDFS site, right? You have MapRed site, then you have masters, you have slaves, right? Masters and slaves are what? Name node will be master and data nodes will be slaves. So assume that this machine is the master. So I'll just open it and I have to specify IP address of the master, right? Which is localhost as of now. Okay. Now same in slaves, I can go and specify who all are my slaves, localhost 1 or IP addresses of all slaves. So that when Hadoop cluster starts, it goes to slaves.xml, gets all IP addresses of slaves, pings them and make part of the Hadoop cluster. Okay, is that clear? David, are you getting right how actually we'll be doing practicals and all? Fine. Then you have one very important file here. You have a file called as HADOOP So this file is actually used in order to set up the actual environment. I'll just go here, open it, and if you see, we have certain important tasks that we have to do, like Java home, right? Which Java you want to use. Your machine can have more than one Java installed, so you can go and you can decide which Java you want to use. Not only that, you can allocate memory, heap size, and all of your choice. As of now, we will keep it default, right? So we'll just go and change the Java home for this, and your Java is present here. In Ubuntu, when you install Java, it goes to usr lib JVM. There is a folder now called as JVM. In JVM, you will have your Java. If you see, you have Java 6 Oracle, you have Java 7, you have Java 7 OpenJDK, right? I can take this one also. Let me take Java 7 only. Why to take Java 6? I'll go here and take the properties, which tells me the path. I'll copy this. After copying, I'll come back and I'll make that entry here. So I'm telling which Java I want to use, and I'll uncomment it. I'll save it. Is that clear, Farid? Is that clear, Tejas, Farid, and David and Mohit?
Yes.
Okay, fine. So this change you have made. You will just save it, right? After saving, you will go to your prompt again. Let me go and do clear screen here. And what I'll do, I'll make some environmental variables here. I'll set some environmental variables. I'm writing export Java home equal to user lib jvm and your JDK that you want to be set. So all these environmental variables are required that you can set. See, Java home is set now. You can know what all are the environmental variables which are set. Just write export, and if you see after you set your Java home, your entry will go to this. This is what is your Java home. Now, other environmental variable setting that you have to do is Hadoop home also. Let me clear the screen. I'll go and I'll write export Hadoop install. This actually tells where actually Hadoop is installed, right? You can specify here by just going to your Hadoop folder, and I'm assuming that you are new, so I'm just doing the task which we can do in order to quickly know where our Hadoop is. Let's go properties and copy this. You'll come here and you'll specify. Right. So you have done the Hadoop install environmental variable also. This Hadoop install tells when you start up that which Hadoop you have to use. Like we were talking about having both versions of Hadoop. So when I want to start Hadoop 2, I will go and change this Hadoop install variable with Hadoop 2, right? So all that settings we can do. Apart from this, we can also go and add path so that it becomes a bit faster. Path, this will add or include the existing path, and then you can go and you can add Java home because you have set the environmental variable as class bin. You can add path of Hadoop install also as well. Apart from bin, your Hadoop install also provides you a decent folder called as Hadoop sbin. So in previous versions of Hadoop, you will not have these many files actually, because everything was there in a single file when it comes to Hadoop configuration. You never had distributed HDFS site.xml, core site.xml, right? Everything was supposed to be done in a single file. But now with Hadoop 1.x, they have changed it and they have distributed responsibility across different files. Is that clear? Sorry, just be for next 5 minutes and you will see the Hadoop version. Okay, just 2 minutes. You will take sbin. Okay, I mean to say, David, that assume that I have 2 Hadoops installed on my machine and I want to run one of it. Okay, so that I can do by changing this Hadoop install. Whatever Hadoop I want to run, I can specify that particular Hadoop in my Hadoop install environmental variable. Is that clear?
Yes.
Okay, fine. David, is that clear? Right. So now everything is set. You will just go and finalize it by going and seeing, okay, your path is set or not, Hadoop install is there, right? Then you have Java home also set, right? Then you have in path, whatever path entries you have made, that is also part of it. If you see, you have all paths also updated as per you. Now you want to test whether current Hadoop download is fine or not. What I'll do, I'll just go here to Hadoop 1.2.1. I'll do ls. Okay. All my executables are there in bin. I'll go for bin. I'll do ls, and if you see here you have n number of commands, right? Start all, start EFS, start balancer, start map reduce. Okay, I'll not start as of now. What I'll do is I will just go and check the version of Hadoop which is currently running or which currently is present in my system, right? I'll just write /Hadoop version. And if you get this output, it means your Hadoop installation is done. It is proper. Okay. So you'll be getting, you say, step-by-step guided support from us from initial step, making your operating system ready, making your virtual box ready, downloading, and then setting it up. Once you have done this, then you have to decide your configuration, whether you want standalone Hadoop, you want pseudo cluster Hadoop installation, or you want real cluster where you have n number of systems, right? According to that, you will be making changes to the XML files. Is that fine? David, Fazid, Mohit, is that fine? Okay, good. Farid, just 2 minutes. I'll just show you the lab guide. You have already seen, I feel. So if it is urgent for you, you are getting late, you can leave. I'll just go and show you the lab guide, which is prepared specifically for you people and which you will be getting post session. In the sense, after every session, you will be getting that. And let's show you that. And then you can leave. You go to downloads, desktop. And here you will have guide of this kind. I'm just showing you. Now these are different labs which you will be doing. I will be doing in front of you, and you will be doing it on your system as well, right? And guidance you will get will be of this type. Right? This is what is the lab installation of Hadoop. How to go to terminal, and then how to check for Java version, and then if Java is not there, how to install it, how to do SSH, how to go and configure SSH, that all we will tell. Then you have download Hadoop release, right? So everything is step by step. So even if after I do it here, and if you try it on your place, if you will face problem, you can go and get those steps from here. And this we have for all our activities. Okay, which file you have to open and which file to edit. Not only that, what edits you have to do. So see, Java home we have set up, and here it is keep size. Right, set the path, and then Hadoop version where you are getting this. Till here is what we have done. End of lab 1. After this, we will start up with configuring Hadoop in pseudo distributed mode, where you have to create certain folder, why you are creating, what permissions you have to give. All that I will discuss with you, and we will ensure that in next session we have our Hadoop cluster running. Any questions you can ask me. David, any question you have? Mohit?
How many sessions are there?
Yes?
I actually have one
Any
question.
Yeah, ask it, yes.
Yeah, so with Hadoop being all about, multiple machines, how will we manage, doing or practicing with only one machine that we have, or do we have to install just multiple machines?
Okay. See, we will be installing 2 virtual machines here, because when it comes to actual production, you will have hundreds or thousands of machines also sometimes, right? But when it comes to configurations, it will be common. So if you know how to commission a data node in my existing cluster, what entries need to be made at the client end or on the data node, that will be fine. Like that, you'll be able to do it, right?
Right. So we would actually have to have at least two machines installed on the virtual machine.
Yes, you should. When it comes to basic configuration of machine that you need at your place, it is you say 8 GB RAM, where we can have now 2 or 3 machines. Okay. 2 or 3 virtual machines, and we will do virtual networking also among them, so that you can get the feel. And as I told you that we will be doing this on cloud also. So I'll show you how Amazon EWS supports Hadoop and how actually you can quickly go and replicate data nodes. You can have hundreds. Not only that, I will tell you about rack configuration also, where you will have n number of racks, where each rack will have n number of machines, right? And for that also we have tools to do that. Okay, on a high capacity machine, we can even go and implement racks. Right, so that all we will make possible. You will see that it is possible on your PC. Important is configuration. Important is to know the network, understand the network topology, and then identify how Hadoop is or can be clustered. If it is already clustered, if you have to just go and see the properties file, you have to explore a bit of network which is there. You have to know what switch they are using, what is the capacity of that switch, right? How inter node or inter rack communication is enabled. All that we will discuss.
Okay.
Okay. So, David, it will be 40 hours of session. Probably it may increase 1 to 3 hours, depending on your you say issues or on problems or on questions. But as such, it is 40 hours, which includes projects also.
Okay.
Okay. Any other questions? If you have any questions, yeah.
How much is the course?
This regarding fees and all, I feel Anthony will talk to you.
Okay.
I'm just responsible for technical tasks, right? Technology and also all that he will talk to you.
And you'll be sending a copy of what happened today?
Yes.
Okay. Okay.
It will be in similar way, and we will be setting up environment at your end also. So.
All right.
And at the end of the session, you will be certification compliant plus ready to go on job.
That would be good. I'm curious about. I'm reading up a little bit on it. How big data is starting to become more available for even medium-sized, smaller companies as well. And so I was kind of, how big is the market? You know, I do some
market
search.
Is market is too big, because if you see, when we talk about market of big data, as of now it is not that mature. But with growing need, because each and every organization, or you say for that matter, each and every enterprise need to give value to the data. For example, why do I need to go and store click streams? Because it tells me, it provides me good input that what all pages are there where client is going and for how long client is there.
Right.
So from direct business perspective, it may not be useful, right? But if you see indirect, you have lots of benefits. You can go and customize pages. You can know which page is bringing in traffic to your site, which page is not bringing in traffic, and you can customize your task. Earlier, people used to maintain archives, and they used to just delete it because of storage problem and all. So Hadoop comes with that particular solution. So if you see, market is going to be potentially big, and not only me, like if you see research and all, and if you see investment which is being made by various companies like IBM or EMC square. It's huge. It's more than 15 or 20 billions which they have invested on big data project itself. So if you see big data opportunities, they are huge. Demand of information management specialists in all software AG, Oracle, IBM, Microsoft is increasing because all of them have done huge investment. So they are also seeing the potential in market.
Okay. Okay.
Right. So market will be good, and as far as our feeler goes, means we have certain consulting companies in US, Canada, and also Middle East. Right. We are getting good feelers. Right. Requirements are increasing day by day. Number of consultants which they are asking from us on these technologies are increasing day by day. Number of projects that we are getting to set up architecture of big data, they are also increasing. So we are getting that feeler from market that yes, slowly big data is picking up. Okay.
Yes. Just one more. In the courses, is I go to the website, highlight courses, highlight Hadoop Big Data, and then it breaks down to Big Data Essentials and Hadoop. Are those two different courses or just two parts of the same one?
Yeah, these are two different courses. When it comes to Big Data Essentials, there our objective is to make people aware about what big data is about. We will do analysis of various type of scenarios where big data streams can be created, and we are talking there in brief about all big data technologies like MongoDB, Cassandra, as well as Hadoop. Right. So you can say that is for people who want to have architectural understanding of when to use which big data solution. And when we talk about only Hadoop course, objective is to create manpower where they are able to administrate Hadoop cluster and do analytics using Hadoop. So they are two different courses. Objective of those two courses are entirely different.
Okay, so like Essentials is an overview and Hadoop is a specific.
Yes.
Okay. All right. Well, thank you. That's all the questions I had at this time.
Thank you, David. Thank you very much. Okay. Farid, thank you for being there. Tedious, thank you. Mohit, thank you once again. I feel Deepak will meet me offline. Thank you all for joining, and we'll be starting our first session from I think Monday, and that is where we will do setup of our Hadoop cluster. Second task will be to set up ecosystem products. Third task will be to grow our cluster. Fourth task will be to apply security on it. Fifth task will be to set up a monitoring system. And after that, we will start doing analytics using Java, using Pig, using Hive, right? And once everything is done, we will come up with a project where we will set up multi-rack cluster using some assisting software, and we will put everything together. Okay, that is what will be the way we will move forward. Fine. So thank you very much. I'm still open for any questions, but if everything is clear to you, I'm fine. We can end the session. Thank you for joining in once again.